All right, friends. Another little tutorial for the mutation part. So this is going to be on the very last part of the test. That's okay, I don't have a copy. That's fine, I can make something up. Okay, so on the last section, very last page, section 4, we're working on a few things. So first of all, you're showing me that you know how to finish DNA replication, okay? So what that means is, this is a model, one of y'all made this is a model of DNA, right? So when DNA is replicated, there's a great video on Google Classroom that you need to go and watch that will animate the process of replication, okay? So I'm just gonna do a quick version of it right here. So what happens when we've got this strand of DNA, in order for it to be replicated, you'll see in the video, you have to pull apart these bases. Remember, these are bases in the center that are held together in the middle by hydrogen bonds. So you're gonna pop those apart, and then you have 2 open strands that don't have a partner anymore, right? So when our body puts new partners on each side, you go all the way down, and so eventually you pop everything apart and you replace everything that was missing. And so that is, in a nutshell, what's going on with DNA replication. So the way we practice that on paper is that I give you a strip of half DNA. So I've already popped it apart, and you're looking at 1/2 of it, okay? It's the best I can do with just me typing and things like that. So if I were to give you a strip of DNA, half a DNA, so remember, these represent the bases, the C, G, A, T, and so forth. And so you would need to bring in the missing partner in order to finish replication. So if I'm doing replication, it's DNA, it's all DNA still, right? So we have A, we have T, we have C, we have G, because replication is DNA, okay? So if this is a C, I'll do a new color so you can see. So if this is a C, the complementary partner, that's the word I use in the test, would be the G. Remember we talked about C and G go together? I hope you guys can see that. Again, C is going to be paired up with another G. If I have a G on this side, then I need to partner it with a C, right? If I have an A on this side, I need to partner it with a T. T partners with an A, G, and C. So we would have finished what we call replication. That's what it looks like when we do it on paper, right? Now, once I do this, I believe in the test, I ask you to now use this strip of DNA that you just created, and I ask you to transcribe it or do transcription. Well, you need to remember what transcription is. It's in your notes. I believe you got a video on it, and it's talked about in the book. So transcription is when I take this strip here and I make an RNA molecule out of it, right? So this is going to be transcription. So in this case, we still have C pairing up with G, but my A and T, you've got to be careful because RNA does not have a T for thymine. So if I'm making RNA and my brain is thinking I need to put a T for thymine, I've got to switch gears and I've got to put a U for uracil instead. So when I do transcription, which means I'm making an RNA copy, G still pairs with C, C, G, T still pairs with A. RNA has an A for adenine. Here's where we've got to make the substitution. A, up here I'm paired with T, but down here I'm making a U instead. I'm bringing a uracil in, and then I have a C and a G, right? So then once you have this for transcription, you're going to take every 3 bases, okay, and then this is where you're going to look them up in the square, in the code there, all right? Again, there is a video that talks about gene expression, transcription, translation. You can practice. It's like hands-on. So I highly encourage you to get on there and then kind of see how the rest of that works. But this is when you would start using that square code. It's called a universal code. And then we've done that in class. I've practiced with, I think, all of you, except maybe those that have been gone for a week or more. So this one you'd be using the square. So what happens is, in that very last question, I'm telling you that there's now a mutation. So the original DNA strand I gave you, I have done something to it. I have mutated it. I have put a change in it. So then what you're going to do is you're going to take that new DNA and then you're going to repeat the steps that you had done before. And I want you to see, how does that change the amino acids? Amino acids, I probably don't have one up there. This is a very tiny version. But amino acids are all the abbreviated things that are inside this universal code. So the LEU, the ASP, those are abbreviations for amino acids that work together to make proteins, all right? So that is what's going on in the last one. So you're just taking that new strip of DNA that I have changed, I've mutated, you are giving me the other side of it, you are transcribing that, and then you're translating that, because I want you to see how the amino acids change with the original strand versus the mutated strand. So these abbreviations in your mutated strand of DNA should be different. The amino acids that you write down should be different than they were when you did your transcription translation the first time. So that is what I'm asking you to do. Do the best you can. Make sure you come in with questions on Monday. Email me. I think that's it. I guess I can talk a little bit about the pedigree. Just a quick reminder in case you weren't here. Pedigree is just a chart. I should be able to pull one up here. Just kind of a flow chart that follows a trait throughout a family, right? So as we talked about in class, a square represents a male and a circle is going to represent a female. This line here means that there are children that come from this relationship, right? So this line, and then every individual that comes from this, oh, there you go. Every individual that's like on this line where it comes down would be a brother or sister, okay? So this would be a child, a brother, over here would be a sister. Notice how this one right here is not connected because this is someone who married into the family, right? So this would be a boy in the family who got married. Here's a female, and then we see their children coming from that. So that's what those lines mean. Now, you might ask, why is it colored in? So let's say this was following the trait of taco tongue. We talked about that a lot in class, when you can make a U shape with your tongue. So if something is colored in, then that means, yes, they have the trait you're talking about. They have the disease, the condition, the trait, the ability. They can do the thing that we're talking about, okay? They have what we're talking about. So if this was taco tongue, that means, yes, she can roll her tongue into taco shape. He can, she can, these boys can, she can. So then that's all that's showing you, right? And so what I want you guys to do, there are some genetic traits that are pretty easy to distinguish, whether it be taco tongue or something about your ears, but there's some pictures and some descriptions, I guess, on Google Classroom, so you can choose one of those, and you can just ask your family, you know, hopefully mom, dad, and then you and any siblings you have. That's enough. That's all I need for the pedigree. If you can speak to some grandparents and you want to go a generation up, that's totally fine. If you get it started and have questions, I'll give you a little bit of time to ask me on Monday before we jump into our next thing. And of course, you can always email me or whatever. We'll figure it out. But another one you could add that's not on that page is freckles. So if someone does have significant freckles, then you would color them in. And if they don't, just clear skin, no freckles or anything, then you would leave it open like this. All right, so that would be, again, known as a pedigree, just a way to follow traits throughout a family. So there you go for today. Good luck, and I'll see you guys on Monday.